Hello everyone, welcome to online video lecture series developed by Jawaharlal Nehru Technological University Kakinada in association with Andhra Pradesh State Council of Higher Education. This is Dr. M. Prem Kumar, working as professor in the Department of Electronics and Communication Engineering, Sri Vishnu Engineering College for Women, Bhimavaram. Today's class, we will solve some more problems on convolution sum. Let us consider another example. X of n to the LTI system is given as V of n, and its impulse response H of n is given as full figure. And the equation is to be a over n. And response of the LTI system, and you are asked to calculate token because it's a unit step function. This is H of token, and this is X. Asked to calculate its convolution between X of n and H of n. So this is equal to n convolution between X. This convolution is complete. So of n is equal to summation X of k, H of n minus k. K is equal to minus infinity plus also equal to summation H of k, X of n minus k. So depends upon your convenience, you can take one sequence constant either X of k or H of k. So here we will see, we will keep this H of k constant and we will vary this X of n. Let us draw these graphs once again in terms of H of k and X of k. K samples are given like this. This is starting from 0 to n1. Its function is slightly different. This is ak. Similarly, this is starting from n2. We will be having the same type of this n1, and this is a this is H of k. Coming to the X of k, X of k is given as unit step function. Okay, so now if we calculating y of n is equal to summation H of k, we are keeping H of k constant, X of n minus k. Okay. For different values of n, we have to plot this X of k. As long as n is negative, this indicates n. This is X of well, I'm keeping constant. This becomes X of n minus k. Time shifting operation for n less than 0. For n equal to 0, it is just mirror image of this one. This is the mirror image. This is 0. This is X of minus k, which is equal to X of n minus k for n 0. N equal to 0. Similarly, you can find for n greater than 0, so n will be somewhere here on the positive side. Pulses are coming, keep on coming. This is n. So if you observe here, as long as n is less than 0, there is no overlap portion between this and between this, because we need to multiply h of k with h of minus k. H of k values are starting from 0 to first values of n. And h of n minus k values are available between minus infinity to n. So till n less than 0, so output y of n will be equal to 0. Okay. Now at n equal to 0, y of n value if you have to calculate, now we have to multiply this x of minus k value and this h of k value. One sample will overlap here. Okay. For any other value, n is greater than 0, so this unit step function will be keep on coming, and somewhere here, this is n. Whatever may be the n value, always overlap portion is between 0 to n. So because impulse response is split into two different intervals between 0 to 1 and n2 to n2 plus n1. So first we will try to consider the first overlap portion. This is 0, this is n1, and this is h of k. Now I am taking x of k. X of k, the periodic, you can say x of n is, so this one. So it will overlap here. This is n. The overlap portion is from 0 to n only. So in this case, y of n will be equal to summation h of k, x of n minus k. K is equal to 0 to n. So h of k value will be a power k. So u of n minus k value is 1. So this is summation k is equal to, if you simplify this equation, 1 minus a power n plus 1 by minus a. This equation holds good as long as m is less than n. Now coming to this n value will be in between 0 to n1. Output y of n is minus a power n plus 1 by minus a. Now we have to consider the next interval. N value will be between this one. N value will be between this n1 to n. If n value is in between n1 to n2, the overlap portion always from 0 to n1 only, because after n1 there are no samples. So output will be equal to, so y of n will be equal to summation a power k, and this value is 0, so 0 to this limit becomes n1 only, because if you observe this graph, overlap portion always starts from this is n here, always starts from this 0 to n1. As long as n value lies in between n1 to n2, the overlap portion is from 0 to n1 only. So in this case, y of n value will be equal to this one. If we simplify this, 1 minus a power n1 plus 1 by n minus a. Next value of n in between this value is n2 and this is n2 plus n1. So next value n value will be between n2 to n2 plus n1. So in this case, y of n value will be equal to this entire overlap portion plus next a small overlap portion between these samples. So y of n values you have to consider a power k. K is equal to 0 to n1 plus next term summation will be k is equal to 0 to not cap n, this is small n, small n, small n a power k. So if we simplify this equation, so what you will get is 1 minus a power n1 plus 1 by 1 minus a plus 1 minus a power n plus 1 by 1 minus a. As long as n value is in between n2 to n1. Okay. In the next case, if n value is in between greater than n2 plus n1, the overlap portion always between 0 to n1 and n2 to n2 plus n1. So in this case, y of n value will be equal to summation a power k, and k is equal to 0 to n1 plus another summation k is equal to 0 to n1 and a power k. So if you simplify this, 1 minus a power n1 plus 1 by 1 minus a plus 1 minus a power n1 plus 1 by 1 minus a. So if you simplify this, this is equal to 2 into 1 minus a power n1 plus 1 by 1 minus a. So if you observe the final equation, so y of n value will be equal to 0 as long as n is less than 0. And its value is 1 minus a power n plus 1 by 1 minus a if n value is raised between 0 less than or equal to n less than or equal to n1. If this value is 1 minus a power n1 plus 1 by 1 minus a, this n value is less than n less than or equal to n1. If this is equal to in between n2 equal to n less than or equal to n2 n1, this value is 1 minus a power n1 plus 1 by 1 minus a plus 1 minus a power n plus 1 by 1 minus a. So next value is this is n is greater than or equal to n2 plus n1. This value is twice 1 minus a power n1 plus 1 by 1 minus a. So x of n is unit step function because impulse response is prepared to different intervals. Finally, you will get output y of n is also in terms of different intervals.